In number 25, Part B. Rather than use the standard definition of addition and scalar multiplication in R2, suppose two operations are defined as follows. So we're looking at Part B, and Part B says that the operation of addition between these two ordered pairs is always going to be the first number of the first ordered pair, comma 0. And scalar multiplication, c times x comma y, is our traditional scalar multiplication. So thinking about the 10 axioms, will all of them be satisfied under these conditions? Well, I'm going to focus on axiom 4 this time. If I can come up with a vector, so let me choose a vector 2, 3. That's an ordered pair. If I add that vector to some other vector, I'm supposed to get 2, 0, according to this definition. Well, what if my vector is 0, 0? This is where I'm taking a vector and adding the 0 vector to it. Well, axiom 4 says I'm supposed to get the original vector. But this definition of addition is saying I'm supposed to get this. So axiom 4 doesn't work under this definition of addition. In Part C of number 25, the addition of the two ordered pairs is our standard operation. In other words, if you add two ordered pairs, you do so by combining the x's and combining the y's. But scalar multiplication, if I'm multiplying a scalar by any ordered pair, I'm supposed to get the square root of that scalar times x and the square root of that scalar times y. Well, that's a pretty easy one to break. Suppose that I focus on scalar multiplication. Let c is any number, so let me let that scalar be the square root of -5. Well, that's not a real number. So if I'm multiplying the square root of -5 by any ordered pair, I'll just use 2, 3. I'm sorry, I got ahead of myself. C is not the square root of -5. My scalar is -5. C is -5. But scalar multiplication is defined to be the square root of that scalar times x and the square root of that scalar times y. Instead of regular scalar multiplication, where I would just distribute -5 over each, it's telling me that I'm supposed to say the square root of -5 times 2 and the square root of -5 times 3. Well, we can't do that because the square root of -5 is not real. So this operation isn't going to work for any scalar. Therefore, it breaks that axiom.